Hello YouTube, today we are going to look at how to factorise a quadratic. This method that I'm about to teach you is called the old Razzle, Dazzle, splitty-uppy, factorisy, the lefty-righty technique. Now, it might not be called this in the textbook, but that's because the textbook are written by idiots. They don't know what they're talking about. So welcome to the old Razzle, Dazzle, splitty-uppy technique. Now, this is going to work for every quadratic with integer roots, so whole number roots. So if our quadratic comes along and it lands on some really nice whole numbers, so for example say that's 1 and 3, then we're going to be able to find these roots. Okay, but if on the other hand it lands on some horrid fractions, maybe that's 4/5 or something, this method is not going to work. So what you're going to have to do instead is complete the square or use the quadratic formula, and I might just do a video on those one day, who knows. This also won't work if there are no roots whatsoever. So say I have a quadratic, for example x squared plus 5x plus 3 equals 0, and there are no values of x which make this equation true, which makes this quadratic equal 0. There aren't any values of x. I can go all the way along the x-axis to infinity and back, and I'm never going to find a value of x that causes this particular function to equal 0. It just doesn't exist. So you won't find roots because they're not there. There are no roots if something called the discriminant is smaller than 0, and again maybe I can talk about the discriminant at another time. So what this will do is it will find the roots if they're whole numbers. What this won't do is find the roots if they are horrid fractions, and what this definitely can't do is find roots that don't exist, because things that don't exist can't be found. Or can they? I'll leave you with that. So here we go. Let's do the old razzle dazzle split up of factorising lefty righty technique. This is going to look like a series of arbitrary steps, but after you've cranked the handle on this one 5-10 times, it's very natural. Okay, so stick with me in this first couple. You'll be like, what the hell is going on? But trust, this becomes so instinctual very quickly. So let's jump in. All right, here's what I'm going to do. I'm going to take the leading coefficient in front of the x squared term, and I'm going to multiply that by the constant term. Okay, so in this case there's a hidden 1 there, so that is 1 times 2, all right? So 1 times 2 is 2. I'm then going to look at the coefficient of the x term. Okay, so in this case that's 3, add 3. Okay, I'm now looking for a pair of numbers. My pair of numbers must multiply to give me 2, and they must add to give me 3. The best way to do this is to just go through the multiples of whatever it needs to multiply to equal until you find a pair that also fit this second condition, that add to make the coefficient of the x term. So this one's probably the easiest ever, so I'm going to think 1 and 2. Oh look, 1 and 2 multiply to make 2, so this is satisfied. 1 plus 2 adds to make 3, so this is satisfied. Okay, step 1, hang in there, I promise it all makes sense. What we're going to do now is we're going to rewrite this quadratic. So I'm firstly going to give myself more room here, that second quadratic can go away. I'm going to rewrite this quadratic, so I'm going to rewrite this as x squared plus x plus 2x plus 2 equals 0. Notice nothing has changed from the first quadratic to the second quadratic. It's equally true to say x squared plus 3x plus 2 equals 0 as it is to say x squared plus x plus 2x plus 2 equals 0. It's the same thing. Now, here's where we do the imaginary splitty factorisy bit. What I'm going to do is I'm going to draw an imaginary line down the middle, so between the two x terms that I just split up. Excuse me, one second. Now, I've got two halves. What I'm going to do is I'm going to factorise the left-hand side as much as I can. So all I'm looking at now is this x squared and this x. I'm going to see how I'm going to factorise that as completely as possible. So I'm going to look at the highest common factor between x squared and x. I think the highest common factor there is just an x. So I'm bringing an x out, this will be x plus 1. I'm going to assume that this factor that this factor that I found, this linear factor, x plus 1, is also a factor of 2x plus 2. So I'm just going to assume that x plus 1 is a factor of 2x plus 2. And now I'm going to do a bit of a number hunt. I've got to connect these, so I've got to put a plus there, and I've got to think of a number that I can put in the blue box that I've just drawn that make the right hand side true. So I want this right hand side to have not changed in value at all. I want this to still equal 2x plus 2. So I'm thinking, what number can I put here in this place so that if I was to expand this bracket back out, okay, we would still have this right hand side. Well, what number is going to go there? The number that can go there is, yes, it's going to be 2. So if I put a 2 there, 2 times x is 2x, 2 times 1 is 2. So you see we haven't actually changed the right hand side at all, we've just factorised it. Now what I'm going to do is I'm just going to collect the terms together, okay? So I'm going to have my factor of x plus 1 here, and I'm going to collect these other terms. This is going to be x plus 2 equals 0. Okay, so the x and the 2 as the coefficients of that linear factor x plus 1 being grouped together. So that's it, that's factorised. And all we're going to do now is we're going to crank that handle again and again and again and again until we've absolutely got it. So let's have a look. Here we go. Right, see if you can guess the steps. Okay, so firstly, the coefficient of my x squared term multiplied by the constant term. So I'm looking for mult, 1 times 4 is 4. I'm looking for two numbers that add to make 5. This is also a very easy one, so I think that's very easy. 1 and 4. Does that work? 1 and 4, they multiply to make 4, yes. 1 plus 4 addition adds to make 5. We're going to go ahead and rewrite, but first I'm going to give myself more room. Boom, there we go. I'm going to rewrite. This becomes x squared plus x plus 4x plus 4 equals 0. Imaginary line, hidden with the old Razzle Dazzle. Now that we've hidden with the old Razzle Dazzle, I'm going to factorise this side as much as I can. X plus 1, I think that's even the same factor as we had before. X plus 1 equals 0. Now, what number must go in this position? Yeah, 4. That's a 4. I'm going to collect the terms together. X plus 1, x plus 4 equals 0. Bow, 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 and we are done. Okay, let's look at this one. Here is my coefficient of the x squared term. This is my constant term. I'm going to multiply them together. 2 times 3 is 6. So I'm now looking for two numbers that multiply to make 6. I'm looking for two numbers that add to make 7. I swear I've got the easiest ones. I've given myself an easy run here, and that's not necessarily helpful. 1 and 6. 1 and 6 multiply to make 6. They add to make 7. So we can jump in and get stuck in here. So I'm going to go ahead and go 2x squared plus x plus 6x plus 3. I'm going to do an imaginary dotted line. Here we go. I'm going to factorise this left-hand side as much as I can. Now I can see the biggest common factor that I can spot is just x. So this is going to be 2x plus 1. I'm going to assume 2x plus 1 is also a factor of the right-hand side, and I'm going to see what coefficient I have to put in front of that factor to make this true. I think that's going to be 3. So I have 2x plus 1, and then collecting the other terms, x plus 3 equals 0. Factorised. Here we go. 2x squared minus x minus 6. So I'm looking for two numbers that multiply to make minus 12 and add to make minus 1. Okay, here we go, more interesting. So 1 and 12 does not work. 2 and 6 does not work. 3 and 4 could work. Plus positive 3, negative 4 works. So these two multiply to make minus 12. Positive 3 times minus 4. They add to make minus 1. Okay, so we're going to first give ourselves some more room. Then I'm going to rewrite this quadratic. So that becomes 2x squared plus 3x minus 4x minus 6. Okay, we're going to do our dotted line, hit with the old Razzle Dazzle. Okay, now the highest common factor of 2x squared and 3x, I think the biggest common factor I can spot here is just this x. So this is going to be x, this will be 2x plus 3. I'm going to assume this is a shared factor over here, 2x plus 3. Okay, and I'm going to go minus 2 is the number that works there. So minus 2 times 2x gives me minus 4x. Minus 2 times 3 gives me minus 6. So I can collect the terms and I have 2x plus 3. X minus 2 equals 0. Was that, yeah, it started off on this equation. Okay, we're jumping in with this one. So I'm looking for two numbers that multiply to make 3 times 8, 8, 16, 24. And they must add to make 10. So I'm going to go through and have a look and see if I can find it. 1 and 24 doesn't work. 2 and 12 feels like it could work, but it doesn't. 3 and good God, man, 3 and 24 divided by 3. Sometimes it happens, even to maths teachers. 24 divided by 3 is 8. 3 and 8. 3 and 8 doesn't work. Hilarious. Okay, 4 and 6. Boom. There we go. That was hilarious. And it's on camera. So my bad maths is on camera. 4 multiplied by 6 gives us 24. Tick. 4 add 6 is 10. Tick. Okay, so we can rewrite this. 3x squared plus 4x plus 6x plus 8. This is just an expression, so there's no equals 0 there. Dotty dotty. Highest common factor looks like it's just x, so that's x. 3x squared plus 4. I'm going to assume this factor is shared. 3x squared plus 4. I'm going to look to see what I can put as the coefficient of this term. I think that's going to be plus 2, and that works. So we have 3, oops, hang on, sorry. If you factorise out this x, that doesn't work. Right, we're going to have to do that one again. Okay. So, I'm going to look and see what I can factorise on both sides. On this side, I notice the only thing I can really take out is this x. So that's 3x plus 4. I'm going to assume this is repeated, 3x plus 4. I'm going to look at what the coefficient has to be on this second linear term, and I think that's going to be a plus 2. That works. 2 times 3x is 6x, 2 times 4 is 8. So I'm going to group my terms together. That's 3x plus 4 and x plus 2. I think I've just got a couple more for you guys. So here we go. I've got to find two numbers that multiply to make 4 times 15, so that's going to be 60, and that add to make 16. I might have to jump in with a calculator to help me on this one. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 6 and 10. Hey, 6 and 10. So 6 and 10, multiply to make 60, add to make 16. Good. Let's rewrite this bad boy over here. So I've got 4, let's do it up here. So 4x squared plus 6x plus 10x plus 15. No equals 0, it's just an expression, not an equation. Dotty dotty. What's the highest common factor? I think 2x. 2x can come out, and that would leave me 2x in there plus 3. 2x times 2x is 4x squared. 2x times 3 is 6x, so that's 2x plus 3. And what has to go here? Plus, I think, a 5. So that's going to be 2x plus 3, x plus 2x plus 5, excuse me. 2x plus 5. Last one. Last one. We'll call this one the last one. I think you guys would have got it by now. So I'm looking for two numbers that multiply to make minus 10 and that add to make minus 3. That's quite a fun one to end on. So 1 and 10, 2 and 5, I think plus 2 minus 5 fits the bill. So we've got multiply to make minus 10, yeah, add to make minus 3, yeah. So let's quickly rewrite. X squared plus 2x minus 5x minus 10, and that's just an expression, so there's no equals 0. Let's factorise. X plus 2, x plus 2 minus 5, x minus 5, x plus 2. Alright, I hope that helped. We'll be working our way through the quadratics chapter, so we'll look at the discriminant. That's very interesting, what it all means. Lines, meeting, circles, all of that fun stuff. We'll look at the completing the square, we'll look at the quadratic formula. All of your quadratics needs are met right here, so smash like, hit subscribe. Thanks for watching, peace and love, and I'll see you next time.